A very good morning to all of you. This is your mathematics class of grade 8, chapter 16, playing with numbers, and this is my lecture number 1 of this very chapter. Dear children, in your earlier classes, you must have learnt about natural numbers, whole numbers, integers and their properties. In this chapter, we shall understand 2-digit and 3-digit numbers in generalized form, how to write them in usual form, and we will learn some games with numbers. So let us see how we will be learning to write the numbers in generalized form, usual form, and we will learn some games with numbers. First of all, numbers in general form. Let us understand how to write a 2-digit number and 3-digit number in generalized form or numbers in general form. We will understand how to write numbers in general form. So let us consider a 2-digit number 35. I am taking an example of a 2-digit number 35. So here in this example 35, 3 is at tens place and 5 is at ones place. And it can be written as 35 is equal to 30 plus 5. Obviously, the way we speak, we have written like that only, 30 plus 5. Now as 3 is at tens place, so it will be multiplied by 10, plus as 5 is at ones place, so it will be multiplied by 1. So 35 will be written in generalized form as 10 into 3 plus 1 into 5. Let us take another example. 49 can be written as 49 is equal to 40 plus 9 is equal to 10 into 4 plus 1 into 9. As 4 it is at tens place, so it will be multiplied by 10, and as 9 is at ones place, so it will be multiplied by 1. So 49 will be written in generalized form as 10 into 4 plus 1 into 9. So in general, a 2-digit number AB can be written in generalized form as AB is equal to 10 into A plus 1 into B. Here in this example, A is at tens place, so it will be multiplied by 10. B is at ones place, so it will be multiplied by 1. Simple as this. So it will be equal to 10A plus B. Similarly, BA will be written as 10 into B plus 1 into A. So here in this example, B is at tens place, so it will be multiplied by B, 10, and A is at ones place, so it will be multiplied by 1. And it will be written further as 10B plus A. So BA in generalized form will be written as 10B plus A, and AB in generalized form will be written as 10A plus B. Let us consider a 3-digit number 257. In the previous slides, we have seen how to write a 2-digit number in generalized form. Now in this slide, we are going to learn how to write a 3-digit number in generalized form. And here I have taken the example of 257. So it can be written as 257 will be written as 200 plus 50 plus 7. We all know this. How to write this number 257? It will be 200 plus 50 plus 7. Here 2 is at hundreds place, 5 is at tens place, and 7 is at ones place. So 100 into 2 plus 10 into 5 plus 1 into 7. 2 is at hundreds place, so it will be multiplied by 100. 5 is at tens place, so it will be multiplied by 10. 7 is at ones place, so it will be multiplied by 1. So in general format, if I observe that ABC can be any number, so it will be written as ABC is equal to 100 into A plus 10 into B plus 1 into C. As at hundreds place, we have A as digit, at tens place we have B as digit, and at ones place we have C as digit. So it will be 100A plus 10B plus C. Similarly, if the number is BCA, then it will be written as 100 into B plus 10 into C plus 1 into C. As B is at 100 place, so it will be multiplied by 100. C is at 10's place, so it will be multiplied by 10. A is at 1's place, so it will be multiplied by 1. Now it will be equal to 100B plus 10C plus A. And if the number is CAB, so here it will be written as 100 into C plus 10 into A plus 1 into B. As C is at 100's place, so it will be 100 into C. A at 10's place, so it will be 10 into A plus B at 1's place, so it will be 1 into B. So it will be written as 100C plus 10A plus B. So dear children, we have learned how to write a 2-digit number and a 3-digit number in generalized format. Now, there are few points regarding this to note. The number AB does not mean A into B. As we used to write that if I am writing AB, I normally mean that A is being multiplied by B. This is not the meaning of AB. And the number ABC does not mean A into B into C. Here, A is a digit at 100's place, B is the digit at 10's place, and C is the digit at 1's place, and they will not be multiplied together. It does not mean that these three are being multiplied together. So, the number AB does not mean A into B. Number ABC does not mean A into B into C. Now, coming to usual form. How to write a number in the usual form. Dear children, I will explain this with the help of an example. Write the given number in usual form. If the number is given to you like this, 10 into 5 plus 1 into 6, this is the generalized form. We have learnt in the previous slide. We know that this is written in the generalized form. Now we need to write the number, and that is our usual form. What will be the number with this? It will be 5 is being multiplied by 10. So 5 will be at 10's place. And as 6 is being multiplied by 1, so it will be written at 1's place. So the number will be 50 plus 6, that is equal to 56. So 56 is the usual form of the number which was given to you in your generalized form. Generalized form is 10 into 5 plus 1 into 6. This is your generalized form, and usual form is 56. When you are writing the number from the generalized format, then that will be your usual form. I hope generalized form and usual form are clear to you. We have learned how to write 2-digit and 3-digit numbers in generalized form.
Some more divisibility rules. Divisibility test for 2. If the number has 0, 2, 4, 6 or 8 in its units place, then the number is divisible by 2. Divisibility test for 3. If the sum of all the digits of a number is divisible by 3, then the number is divisible by 3. Divisibility test for 4. If the number formed by last 2 digits of a number is divisible by 4, then the number is divisible by 4. Divisibility test for 5. If the number has 0 or 5 in its units place, then the number is divisible by 5. Divisibility test for 6. If the number is divisible by 2 and 3, then it is also divisible by 6. Divisibility test for 9. If the sum of all the digits of a number is divisible by 9, then the number is divisible by 9. Divisibility test for 10. If the number has 0 in its units place, then the number is divisible by 10. Divisibility test for 11. Find the sum of the digits at the odd and even places. Find the difference between the two sums. If it is 0 or a multiple of 11, then the number is divisible by 11. Some more rules of divisibility. If a number is divisible by another number, then it is also divisible by each of the factors of that number. Let's see how that works. Consider this number 36. 36 is divisible by 9. 9 is divisible by 3. Is 36 divisible by 3? Yes. Consider this number 24. 24 is divisible by 8. 8 is divisible by 4. Is 24 divisible by 4? Yes. Consider this number 90. 90 is divisible by 9. 9 is divisible by 3. Is 90 divisible by 3? Yes. Some more rules of divisibility. If a number is divisible by two co-prime numbers, then it is also divisible by their product. Let's see how that works. Consider this number 48. Factors are 1, 2, 3, 4, 6, 8, 12, 24, 48. Pick any two factors which are co-primes. 3, 8. 48 is divisible by 3 and it is divisible by 8. 48 is also divisible by 3 into 8, which is 24. Consider this number 66. Some factors of this number are 1, 2, 6, 11, 66. Pick any two factors which are co-primes. 2, 11. 66 is divisible by 2 and it is divisible by 11. 66 is also divisible by 2 into 11, which is 22. Consider this number 100. Some factors of this number are 1, 2, 4, 5, 10, 20, 25. Pick any two factors which are co-primes, 2 and 25. 100 is divisible by 2 and it is also divisible by 25. 100 is also divisible by 2 into 25, which is 50. Some more rules of divisibility. If two numbers are divisible by a number, then their sum is also divisible by that number. Let's see how that works. Consider the numbers 20 and 40. Both these numbers are divisible by 10. 20 plus 40 is equal to 60. Is 60 divisible by 10? Yes. Consider the numbers 35 and 55. Both these numbers are divisible by 5. 35 plus 55 is equal to 90. Is 90 divisible by 5? Yes. Some more rules of divisibility. If two numbers are divisible by a number, then their difference is also divisible by that number. Let's see how that works. Consider the numbers 78 and 26. Both these numbers are divisible by 13. 78 minus 26 is equal to 52. Is 52 divisible by 13? Yes. Consider the numbers 400 and 100. Both these numbers are divisible by 4. 400 minus 100 is equal to 300. Is 300 divisible by 4? Yes. Let's list the new rules again. If a number is divisible by another number, then it is also divisible by each of the factors of that number. If a number is divisible by two co-prime numbers, then it is also divisible by their product. If two numbers are divisible by a number, then their sum is also divisible by that number. If two numbers are divisible by a number, then their difference is also divisible by that number.
Welcome students, this is our revision lecture of Mathematics class 8th, chapter number 6, Squares and Square Roots. Topics which will be discussed in this lecture are meaning of square of a number. First of all, we will review what is the meaning of square of a number. Square number, what do we mean by square numbers? How to check whether a given number is a perfect square or not. Then properties of square number. After that, concept of square root. Then methods to find square root of a number. Let us discuss all these topics in detail. Coming to summary of chapter number 6, Squares and Square Roots. First of all, you should know the meaning of square. Students, you have already learnt about the area of square, which is equal to side into side. So area of square is equal to side square. So we can say that square of a number is the product of the number by itself. Square of a number is the product of a number by itself. For example, 5 square is equal to 25. That is 5 square is equal to 5 into 5, which is equal to 25. Coming to square numbers. What do you mean by square numbers? Squares of natural numbers are called square numbers or perfect squares. For example, in the above case, 25 is the square number and 5 is a natural number. Another example is 16 is equal to 4 square. Here, 16 is the square number and 4 is the natural number. How to find whether a given number is a perfect square or not? Students, all the natural numbers are not perfect squares, so there should be a method to find whether a given number is a perfect square or not. A perfect square can always be expressed as the products of equal prime factors. It means to find whether a given number is a perfect square or not, we need to express the given number into the prime factors using the prime factorization method. Here I have taken two examples. First example is of 16 and another example is of 48. Expressing these two numbers into the prime factors, we will be getting 16 is equal to 2 into 2 into 2 into 2. 48 is equal to 2 into 2 into 2 into 2 into 3. Here, if we have a look, regarding 16, it can be expressed as the product of pairs of equal prime factors. But in case of 48, 3 is left unpaired or 3 cannot be paired. So 48 is not a perfect square number. But 16 is a perfect square number. Now coming to the properties of square numbers. The very first property is a number ending in 2, 3, 7 or 8 is never a perfect square. It means that if a number has 2, 3, 7 or 8 in its units place, then that particular number or those numbers will not be a perfect square numbers like 152, 1028, 6593, etc. Another property is a number ending in an odd number of zeros cannot be a perfect square. It means if a number has odd number of zeros, like in the first case, the number of zeros are odd, that is equal to 1. Second case, number of zeros are 3, that is again an odd number. In third case, the number of zeros are 5, that is again an odd number. So we will say that a number ending in an odd number of zeros cannot be a perfect square. Square of even numbers are even. It means if you are squaring even numbers, the answer will be also even number. For example, 2 square is equal to 4, 4 square is equal to 16. Square of odd numbers are odd. It means if you are squaring odd numbers, result will be again an odd number. For example, 5 square is equal to 25, 9 square is equal to 81. Likewise, another examples can also be taken. Coming to the fifth property, that if a number has 1 or 9 in its units place, then its square ends in 1. For example, 1 square is equal to 1, 9 square is equal to 81, 11 square is equal to 121, etc. Coming to next property, if a number has 4 or 6 in its units place, then its square ends in 6. For example, 4 square is equal to 16, 6 square is equal to 36. If a number has 2 or 8 in its units place, then its square ends in 4. For example, 2 square is equal to 4, 8 square is equal to 64, etc. If a number has 3 or 7 in its units place, then its square ends in 9. For example, 3 square is equal to 9, 7 square is equal to 49, 23 square is equal to 529, etc. Coming to the next property, if a number has 5 in its units place, then its square ends in 5. For example, 5 square is equal to 25, 25 square is equal to 625. Likewise, you can consider another examples also in which a number has 5 in its units place. If a number has 0 in its units place, then its square ends in 0. For example, 10 square is equal to 100, or likewise you can take more examples. Coming to the triangular numbers. Students, what do you mean by triangular numbers? So, the numbers whose dot patterns can be arranged as triangles are called triangular numbers. For example, 1, 3, 6, 10, 15, etc. And if we add two consecutive triangular numbers, we get a square number. Like if I will be adding 1 and 3, these two are triangular numbers, then I will be getting 4, which is equal to 2 square, which is a square number. Another example is 3 plus 6, that is equal to 9. 3 and 6 are two triangular numbers, that is equal to 9, that is equal to 3 square, which is again a square number. 6 and 10, these two are triangular numbers. Together they will add up to 16, and which is equal to 4 square, which is again a square number. So the numbers whose dot patterns can be arranged as triangles are called triangular numbers. For example, 1, 3, 6, 10 and 15. And if we add two consecutive triangular numbers, then we will get a square number. Numbers between consecutive square numbers. Now, another method we have learned is how to find out the natural numbers between the squares of two consecutive square numbers. Like there are two n non-square numbers between the squares of two consecutive numbers, that is n and n plus 1. Let us take an example. There are 18 natural numbers between n square and 10 square, that is 2n. Here n is equal to 9 and n plus 1 is equal to 10. So 2 into 9, that is equal to 18 natural numbers will lie between the squares of two consecutive numbers, that is 9 square and 10 square. If the number is a square number, then it has to be the sum of successive odd numbers starting from 1. It means that if a natural number cannot be expressed as the sum of successive odd natural numbers starting with 1, then it is not a perfect square. This property we will be using later on in the case of repeated subtraction method, which is a method to find the square root of a number. So coming to this property, if the number is a square number, then it has to be the sum of successive odd numbers starting from 1. For example, 3 square is equal to 9. The sum of successive odd numbers from 1 will be 1 plus 3 plus 5, that is equal to 9. Now, coming to Pythagorean triplet, this is a very important concept, that is Pythagorean triplet. Three natural numbers, if I am taking here m, n and p are as three natural numbers, and they are said to form Pythagorean triplet m and p if m square plus n square is equal to p. That is, for any natural number m greater than 1, we have 2m square plus m square minus 1 whole square is equal to m square plus 1 whole square. Now 2m, m square minus 1 and m square plus 1 forms a Pythagorean triplet. Sum of first n natural odd numbers is n square. Now if we will observe the pattern, 1 is equal to 1, that is 1 square. 1 plus 3 is equal to 4, that is equal to 2 square. 1 plus 3 plus 5 is equal to 9, that is equal to 3 square. 1 plus 3 plus 5 plus 7, that is equal to 16, which is equal to 4 square. 1 plus 3 plus 5 plus 7 plus 9 is equal to 25, which is equal to 5 square. So we have observed that if I am adding second step, if I will look at second step, so from second step 1 plus 3, that is equal to 2 square, which is equal to 4. If I am adding two consecutive odd numbers, then I will be getting a square number. And these are triangular numbers also, we have studied in the previous property. So if I am adding three consecutive odd numbers, I will be getting 3 square is equal to 9. If I am adding 4 consecutive natural odd numbers, then I will be getting 4 square, that is equal to 16. Same is the case with 5 square, that is equal to 25. If I will be adding 5 consecutive odd natural numbers, then I will be getting 5 square, that is equal to 25. Likewise, if I will keep on adding n natural odd numbers, then I will be getting the sum as n square. Now, coming to the very important concept of square root. This concept is very important. To find the square root of a number, basically we need to do the inverse operation of finding the square. Like finding square root is the inverse operation of finding the square of a number. And the symbol of this square root is this one. This can be pronounced as square root or under root. Now 1 square is equal to 1, that is square root of 1 is 1, and that it can be written in symbolic form. It will be square root of 1 is equal to 1 or under root of 1 is equal to 1. 2 square is equal to 4, square root of 4 is 2, that is square root of 4 is equal to 2. Now in this chapter we shall take up only positive square root of a natural number. What does it mean? For example, square root of 9 is equal to 3 and not minus 3. Why we are saying so? Because 3 square is 9 and minus 3 square is also 9, but here in this chapter we need to take up only positive square root of natural number. Now, what are the methods, different methods to find the square root of a number? There are basically 3 methods. First one is prime factorization method, and other 2 methods are repeated subtraction and long division method. All these methods we will study in detail with examples. Coming to repeated subtraction method. Suppose we want to find out the square root of 36, and we know that if a natural number cannot be expressed as the sum of successive odd natural numbers starting with 1, then it is not a perfect square. We will use this property and we will keep on subtracting the successive odd natural numbers from the given number till we get 0, and number of times we will do the subtraction, those very steps will tell you the square root of given number. For example, 36 minus 1 is equal to 35. 35 minus 3 is equal to 32. 32 minus 5 is equal to 27. 27 minus 7 is equal to 20. 20 minus 9 is equal to 11. 11 minus 11 is equal to 0. It means starting from 1, I need to keep on subtracting the successive odd natural numbers from the given number till I get 0. If I am not getting 0, it means the given number is not a perfect square. And if I am getting 0, I need to count the number of steps. Here, after till 6 steps, I need to do the subtraction to get 0. So the square root of 36 will be 6. Here 6 odd numbers 1, 3, 5, 7, 9 and 11 are being subtracted from 36 to get 0. So the square root of 36 is 6. That is, in symbolic language you can write like this: square root of 36 is 6. I am repeating this method. Repeated subtraction, as the name indicates, I need to keep on subtracting the odd natural numbers from the given number to get 0. But the condition is I need to keep on subtracting the successive odd natural numbers starting from 1. Like here in this case, 36 minus 1 is equal to 35. 35 minus 3 is equal to 32. Likewise, till I get 0, I need to keep on subtracting. And if I will not get 0, it means the given number is not a perfect square. Here, 6 odd numbers are subtracted from 36 to get 0. So the square root of 36 is 6. I hope this method is clear to you. Coming to prime factorization method. Now, I need to find the square root of 2401 using prime factorization. If it is mentioned in the question, then you are supposed to use that particular method only to find the square root of a given number. Here, after doing the prime factorization, we have come to know that the prime factors of 2401 are 7 into 7 into 7 into 7. And now we need to take only one prime factor from each pair. So, square root of 2401 is equal to 7 into 7, that is equal to 49, taking one prime factor from each pair. Two pairs are there, so one prime factor is to be taken from each pair, and you will be getting the square root of 2401 is equal to 7 into 7, that is equal to 49. I hope this method is also very much clear to you.
Thank you for watching our channel. If video உங்களுக்கு பிடிச்சிருந்ததுனா கமெண்ட் பண்ணுங்க, லைக் பண்ணுங்க, ஷேர் பண்ணுங்க.